Well, measuring horizontal angle. um, There are two methods of measuring horizontal angles. Repetition method is used for very accurate work. In this method, the same angle is added several times mechanically, and the correct value of the angle is obtained by dividing the accumulated reading by the number of repetitions. The number of repetitions made usually in this method is 6, 3 with the face left and 3 with the face right. In this way, angles can be measured to a finer degree of accuracy than that obtainable with the least count of vernier. To measure horizontal angle by repetitions method, we set up the theodolite at the steering point O and level it accurately. Measure the horizontal angle AOB, loosen the lower clamp and turn the telescope clockwise until the object A is sighted again. Bisect B accurately by using the upper tangent screw. The verniers will now read twice the value of the angle now. Repeat the process until the angle is repeated the required number of times, usually 3. Read again both verniers. The final reading after n repetitions should be approximately nx, where x is a size of angle. Divide the sum by the number of repetitions, and the result thus obtained gives the correct value of the angle AOB. Then change the face of the instrument, repeat exactly in the same manner and find another value of the angle AOB. The average of two readings gives the required precise value of angle AOB. The face of the instrument is changed and the previous procedure is followed. Reiteration method. This method is another precise and comparatively less tedious method of measuring the horizontal angles. It is generally preferred when several angles are to be measured at a particular station. This method consists in measuring several angles successively and finally closing the horizon at the starting point. The final reading of the vernier A should be same as its initial reading. Here you can see in the picture the schema of the method. To measure horizontal angle by reiteration method, set up the instrument over station point O and level it accurately. Direct the telescope towards point A, which is known as a referring object. In geodetical measurement, we use the term of referring object. For example, it can be the previous point of our traverse It can be precise geodetic mark of triangulation network, etc. Bisect the telescope accurately and check the reading of vernier as 0 or 360. Loosen the lower clamp and turn the telescope clockwise to side point B exactly. Read the verniers again and the mean reading will give the value of angle A or B. Similarly, bisect C and D successively. Read both verniers at procedure. Each bisection finds the value of the angle BOC and COD. Finally, close the horizon by sighting towards the referring object, point A. The vernier A should now read 360 degrees. If not, note down the error. This error occurs due to slipped, etc. If the error is small, it is equally distributed among the several angles. If large, the readings should be discarded and a new set of readings be taken. Another option is, another kind of work is measuring vertical angle. To measure vertical angle of an object A at a station O, set up the theodolite at station O and level it accurately with the reference to the altitude bubble. Set the zero of vertical vernier exactly to the zero of the vertical circle clamp and tangent screw. Bring the bubble of the altitude level in the central position by using clip screw. The line of sight is thus made horizontal and vernier still reads 0. Loosen the vertical circle lamp, screw direct the telescope towards the object A and sight it exactly by using the vertical circle tangent screw. Read both verniers on the vertical circle. The mean of the two vernier readings gives the value of the required angle. Change the face of the instrument and repeat the process. The mean of the two vernier readings gives the second value of the required angle. The average of two values of the angles thus obtained is the required value of the angle free from instrumental errors. We can also computate latitude and departure with Theodolite. The latitude of a line is its orthographic projection on the north-south axis representing the meridian. Thus, the latitude of a line is the distance measured parallel to the north-south line. Thus, latitude L is equal to L cosinus theta. The departure of a line is orthographic projection on the axis perpendicular to the meridian. The perpendicular axis is also known as the east-west axis. Thus, departure D is equal to L sinus theta. While calculating these coordinates, we can use the table because in different quadrants the latitude and departure obtain different signs, plus and minus. Well, let's move on. Consecutive coordinates. The latitude and departure of a point calculated with reference to preceding point are said to be the consecutive coordinates of that point. Independent coordinates. The coordinates of any point with respect to a common origin are called the independent coordinates of that point. The origin may be a station of the traverse or a point entirely outside the traverse. Balancing of the traverse. A traverse is balanced by applying corrections to latitudes and departures. This is called balancing a traverse. The following are common methods of adjusting a traverse. Bowdish rule, transit rule, third rule, graphical construction method. The Bowdish rule, also termed as the compass rule, is mostly used to balance travels when linear and angular measurements are equally precise. You can see equation correction to latitude or departure of any line is equal to length of the line divided by perimeter of the traverse and total error in latitude departure. Transit rule. The transit rule is used to balance a traverse in which the angular measurements are more precise than the linear measurements. In this case, you can see another equation. Third rule. If the corrections are to be applied separately, then the third rule may be used. You can see the formula. Well, and here you can see traverse area, sketch of the traverse area, and the coordinates method that allows to create this schema yourself. Well, let's move on. And now we try to work with simple tasks, very simple task that we used to let's speak about geodetic calculations.